Hello. Okay, so I'm actually going to go a little bit out of order, although if you're watching this in order, then sorry. I did this one before some of the other lectures. I won't tell you which ones, I'll let you guess in the comments below. Okay, so lecture 10, regular expressions. I'm doing this largely because the next homework depends on this, and so um, hopefully we can get through this particular subject relatively painlessly because while regular expressions are awesome, they're also really painful and something I have to look up every single time that I either have to do them, teach them, think about them. So if you're like me, don't feel bad because I'm like that. But they're also very, very useful. And in particular, if you're doing a lot of text manipulation, tokenization, wacky things with text, or even just like trying to make sure that your inputs to programs are pretty good, regular expressions are really, really good to use, and they're largely supported by almost every language out there. In particular, the sort of, you know, like Python-ish and JavaScript and whatever, and C++ as well. So let's get into it. So what are regular expressions? They're essentially a sequence of characters that define a search pattern. I would even go as far to say that regular expressions are akin to a programming language where the primitives of the programming language are individual characters. And that was a definition that was given to me by a friend one time that I think really put this into perspective. When you think about a programming language, we have things like int and var or, I++, whatever it might be. And each one of those things is essentially a primitive, and we need to use multiple letters for them because we have so many of them, right? We have a lot of options, our functions can be pretty long. I mean, if we had a programming language that only allowed us to use one letter or one character for anything, that would be relatively limiting, right? So we do have to combine multiple characters into words, and even individual words aren't enough for really complex programs. But say you had a programming language that was very, very simple. It only did a few things, right? It only did up to 30 things, and that's all it ever did, right? Well, we could define and use individual characters or combinations of certain characters to basically define this programming language. And that's exactly what a regular expression is. A regular expression essentially is like a programming language where each individual character in that string tells the language what to do. And so sometimes like you can say, oh, this regular expression just looks like apple, but it's not apple, right? The regular expression is actually telling the compiler that we're looking for a character A and then a character P and so on. And so the A isn't actually the contextual information of A as an apple. It is actually a operation that the underlying compiler is doing, which is find A. And after you find an A, find a P. And after you find a P, find another P. And if you don't find one of those things, well, move on to the next thing and look and start over again. So it's this sort of flow diagram. And if you think about regular expressions in that way, I think it makes a lot more sense because sometimes you'll see this like wacky looking character string and it's like, what the fuck is that? Well, if you think about it instead of I need to understand this string like a line of code, you're going to go crazy. But if you think about it like, oh, each one of these characters in the string means something, then you actually have a chance to understand what's going on. And also what's nice, and I'll introduce them and use them in this lecture, there's some really, really great tools out there that show you how to use a lot of these things and let you break it down in a way that doesn't make you feel stupid. Because every time I make a regular expression, I definitely feel dumb. I never really remember how any of the stuff works. I have to look up everything, and it's very frustrating. So using a tool that can help you design your regular expression, no shame, use what you got. Cool. So first of all, these things are pretty old. Regular expressions are, found their way into Unix tools and awk and grep, if you've used those, are still really big parts of ed and v or vim, depending on your favorite, and are definitely a core part of lexers and parser tools. but to a lesser extent. Often parsers kind of do their own thing. Whoops. Um, Regular expressions are essentially patterns, and they allow us to kind of find things that we're looking for in a very expressive way, and can really capture different variations and subpatterns specifically in text. So regular expressions are only applied to text, although if you are crafty, you can find ways to do it for other kinds of data that can be represented as text, which is also actually in machine learning a very common thing, where regular expressions are used to parse through data that is textual in format but was converted to text from some other underlying format. For example, floating point numbers or something. So regular expression forms, we can do it in a couple of different ways. We can match, so the regular expression pattern must match the string or text exactly, or we can search, where we can find the regular expression in one or multiple places within the string. And there's a couple of different ways to do that. So regular expressions are not all made equal. They're all very similar, but there's a couple of different standards, and I can't speak to the specifics of how these are different, honestly. But there's ECMAScript, which I think is the large dominating one. So if you're using JavaScript, for example, you're in ECMAScript land or in Python. You have well, I think Python has its own, actually. So ECMAScript is like JavaScript, and I believe C++ defaults to it as well, as this slide says. And there's also the POSIX standard, which is essentially the Unix standard, and then awk and grep use their own sort of slightly different version. And I'll talk more about this in a minute, but if you're using a tool such as this, regular regex 101, you can actually choose like PCRE, which I didn't mention in the slide, ECMAScript, and so on. But they're mostly the same. There's really very few differences. If you know one, you know it's usually like how many slashes are on things and stuff like that. So this is a slide I added into this lecture, regular expression tools. I just showed you one. Regex 101 is terrific. I can add my string, and then if I write a little expression here, it will show me why the match, and also explain why. For example, if I do D, there we go, it'll match all of these, and so on. And if, I'm really bad at regular expressions, as I mentioned, so I'll get to that stuff in a minute. What's also nice about this particular one is that there's a quick reference down here, and you can kind of look at it. So I'm like, cool, let me do, at the beginning of the string, I want to have A to Z, and then how do you do it with 3? Oh, that's the end. Sorry, that's the end of a string. There we go, and then I can do 3. Yay! Cool. So there. Now I've gotten that guy. Anyways, we'll talk about it. And like I said, I'm not very good at regular expressions, so this will be fun for you to watch me bumble through it. Okay, so the patterns that are in a regular expression, they define the pattern that we're matching and searching. As you saw, if I write in my, if I write in string, say I write something like my string structs, which means nothing. If I do str, you'll see that it'll match multiple locations. But if I add in the u, it's not going to do that. Cool. So, oops. Some characters have very special definitions, like groups, assertions. One example of that is the /d, which is all non-digit, right? If I do d, nothing will show up because it'll only match the values. And if I do something like star, it will only match the values until it doesn't anymore. So yeah, a lot of fun things to do. So you have to be really careful with these patterns because they need to be escaped in C++. And so you can have like a new line or a carriage return But when you're doing, you know, this uh, in regular expressions, you need to escape those slashes. So say I wanted to do slash D, right? That is the special character pattern for the digit that I just showed you. And in C++, you need to do doubled slash to escape that slash. Otherwise, it thinks that you're doing a new line or a carriage return. Similarly, if I want to do a slash, like say I have one, you know, hey there, or whatever, and I'm trying to get to the slash, well, I can't. I have to double slash, right? And then I can do this. Anyways, whatever, I'm really bad at these. But you get the idea. If you're doing something with a slash, you need to escape the slash. A lot of characters mean funky things, like the caret or the dollar. All of these mean, they have special meanings. So if you want to have a dollar sign in here, cool, I want the dollar sign. Well, I can't. That's not going to match it. I need to escape the dollar sign. And if you're in C++, you're going to have to double escape, right? Because in C++, we have to escape the actual thing. So it's very common in C++, all of a sudden you've got like 20,000 slashes everywhere. If you're interested in the syntax, here's the link. Check it out. There are a lot of special character patterns. So for example, slash T is tab, slash N is a new line, or carriage return. These are common invisible characters that we have in strings. And to type match those, you do, you know, you can effectively use them. But say I actually wanted to do the actual one, you know, the actual slash N, that's the way I would do it. But this way, if I have a new line, it'll match the new line, hey, right? So if I write hey here, it'll match this, but not hey here. If I put in hey here, it will not match that hey because there's no new line in front of it. But if I put a new line, well, that won't work. But if I, well, I guess that won't do it. Oh yeah, and if I want to actually do, say, slash new line, I need to escape it, right? So there's kind of the subtlety there and the differences between all of these different things. Sorry if this is kind of small, I can try to zoom in, but okay. Other character patterns, so dot is any character. Let's go through these. Dot, any character. Slash D is any digit character. Slash capital D is any non-digit character. Slash S, very useful, any white space character, which is really valuable because, again, if I do hey, it'll come up. So even new line and carriage return will be included in that. And capital S is non-white space. You can see this pattern of like lowercase is the opposite of uppercase, and this is similar to Vim if you've, well, in some cases in Vim. And then word character, so alphanumeric or underscore or non-word. So useful. And if you're using a tool like this, you can see like all these, it's kind of cheating over here. It shows you all that stuff. You can do class patterns. So brackets mean that you can basically, I want to match A or D or M. And now you'll notice it matches all instances of A, D, and M. And these are 4 separate matches. So this is not like looking for ADM in that order. I can put the M here, and it'll still be the same thing. And if I then put a dot after it, it will then match the rest. So in this case, it's matching AD, and then D, and then MY. You can see that these are all the different matches. If you add in a caret here, it's the opposite. So it's kind of like the opposite of that. I'm going to get rid of this. If you put in a range, you can do the range. So say I want to do A through D. Cool. And this is a way to do alphanumeric ranging for each character match. So you can actually add in multiple ranges if you'd like. Special characters need to be escaped. Escape, except brackets and dash, and POSIX select classes are supported. So if you have predefined patterns, you can do that. I'm not too familiar with that personally. Groupings are really interesting. So you can create these groups and say, okay, I want to put, say, ADD in a group. So now, if I have a full match on ADD, if I put in another one, you can see a second match. And that's pretty useful. I can also do a sub pattern and then reference it later. So one creates a group and the other one creates a passive group. So in this case, you can see there's a match, but there's no, but it's in the same group of 0. Whereas here, I have group 1 and a full match in group 1. So you have two separate matches, whereas here, we actually don't have that. I need to, I guess, to reference a group, what you want to do is then you, really, this is where I'm never quite good at these. Well, let's keep going and then I'll talk a little bit about it. Right, and so, let's see here. I'll talk more about groups let me pause and I'll talk a little bit more about groups actually, because I think this is important. Okay, so I don't know if you can see this. Here we have an example of a couple of different file names, and this is where groups are actually pretty valuable. Because if I do, say I want to match these two, but I don't want to match this last one, the first thing we can see is that they all have PDF in them, right? What? What's going on here? Let me read. Let me refresh the page, reload, I don't care. Cool. So if I put in PDF, obviously we're matching all 3 of these, and that's not what we necessarily want. And we want to put this into a capture group, because now we have 3 different matches, but we don't actually want this to be the case. So the first thing I can do is I can put in the end of the file. So already I'm only matching this. But say I don't actually want to capture PDF. I want to capture the end, just the file name. And so in this case, what I'm going to do is I'm going to, write any, an alphanumeric character, which is W. Oops. Yeah, W. And then dot, but I can't do a normal dot because the dot is, and the fact that it's actually highlighting dot is kind of just by accident. So what I want to do here is I want to have, after my file name, I've got a slash dot, which is escaping the dot, right? And on top of this, I want to capture any alphanumeric value. And you can see, even in this case, now I've captured T and 9, which are the ends of these files. And if I put in a plus, and the plus, it will basically take that pattern and keep going. Now I've got essentially the word, and I've captured, and you can see over here in the match information, we have a full match on the pattern of file record transcript.pdf, but the group has been captured in this way. And that's sort of the way that we want to do it. If we put in this sort of thing here, we have a full match, and then we can actually use the passive group later, which is something that I have never really done. So yeah, it's cool. Then, whoops, the nice thing is that now when we have a back reference, like, we can basically have everything stored as a submatch, and then that subpattern can be used again. And so this is, generally speaking, when you do this kind of nomenclature, you then refer to it later. And that is the, here we go. As you can see, the language of this is quite complex, but I won't go too much into passive groups. Whoops, okay. Whoops, okay, we're back to here. Great. Quantifiers. So we just showed you a plus, so that will precede the previous atom plus one or more times. And with the star is very similar, but it doesn't actually need to be matched, so it's kind of a conditional. The question mark is optional. It doesn't actually have to happen. And then this, the parentheses, it'll repeat the preceding atom a certain number of times. Or in this case, it'll have to be that many or more. Or if you have the full tuple there of min to max, then it has to be a minimum or a maximum number of times. Again, think about this as sort of a programming language that is almost like doing a for. And in this case, you can do a minimum or maximum. The ECMAScript behavior is greedy. It tries to essentially get the maximal number of characters that meet that condition before moving on to the next character. And if you don't want greedy, you use that question mark, which essentially will do that sometimes, and not necessarily. Some assertions you can ask. So we already did this assertion here. Let me get rid of this question mark. In this case, I actually do want to have this this in the beginning. Which, for example, let's say I create a new one that is not a file, and I can add, for example, a file, right? But and yes, whoops, and then I can put a dot here. Cool. So now I have file, and if I take this caret away, it'll also reference this. So what I can do say, well, I only want files that start with the word file by putting in this caret here, which is pretty cool. And what this is saying is I want to find the pattern file, and then any character repeated as many times until we hit a period, which is pretty neat. In fact, I can kind of go like question mark, and what that'll do is it'll go until we find a PDF, maybe. So it includes the dot in my thing if I put the question mark. If I do this, nothing really happens. Okay, cool. You also have the beginning of line. You also have the word character, so /b is a word. And yeah, you can kind of do this with positive negative lookaheads, but it can be problematic in C++. So with regular expressions, you can see the best way to design them is sort of in the designer. So paste in some text that is representative of your problem, and then design the pattern and then apply it. If you're trying to debug regular expressions as well as debug your C++ program, you will go crazy. So alternatives, the line you can do or. So say I want to have file, let me create a test file, not .temp, but I can do, say, file or test file. Oops, file or test file. And so in this case, we're going to capture group 2 because this is a separate group. But we now have both matches of file, this one and that one, which is pretty neat. Although I would have to repeat this there, and now we've got them. In fact, I don't think these are necessary. There we go. So there you go. Now we're capturing all these options. And it's a little bit more readable. To do this in C++ is actually pretty straightforward. You include regex, and then you create an instance of regex, and this string is just a string. It's just the regular expression thing. By the way, there are other tools like regular expression at regexer.com. And what's nice about this is it really gives you this breakdown of how you're capturing this group. And so again, like use this tool or use regex101.com, all very useful. My wife was very thankful to me for introducing her to this tool. It's one of the best things I've ever done in my life, apparently. So, cool. In this case, we have C match versus S match. That's going to be the difference between character-based string like a char array or a C plus a C string, and we have regex match, search, and replace. And so replace can be really powerful in that if you're trying to replace a particular pattern in a string to sort of prep it for some other process, this is a very useful thing to know how to do. And then you can also use an iterator approach to explore all matches found. So in this case, right, we have 3 different matches against one corpus with a particular regex string. And so if you say you want to go through each one and then handle each one separately, you would use the iterator approach in C++. So this is an example from this particular link. Feel free to go there. This is the non-iterator version. So what we're doing is we're hitting the regex search with a particular string that we've passed in, and we're going to get the matches. All right, and so first we set up our stuff, and we show true and false in the output, and then what we're doing is we're hitting the string, the input string, with the matches and the regular expression, and then we see that we check for results. We have this many matches. This will tell us if it's empty. This will tell us the number of matches, and it'll tell us when it's ready. And then it'll get the first match, eliminate that one, and move on. And so what we're doing here is we're going, while this is true, while we have a match, we go through and we go through until there are no longer any matches left. Right, so here we are essentially eliminating the previous match and creating a new string to search. Great. I'm sorry. It hits all the matches in this one. It's not iterating and doing it over and over again. So it's not like a tokenizer. This is just generating. What? Hold on one moment. Okay, sorry. I was correct the first time. This is kind of a weird approach, and I really don't recommend it. But essentially, yeah, it's hitting the regex. It matches one time. If there are no matches, it hits empty. But that should never happen because this would never go into the while loop in the first place. This is kind of inefficient code. Then we pass in, we output the match, and then the suffix of matches will essentially give you the part of the string post the that comes after the regular expression has been satisfied. And so it's essentially taking our string and getting rid of all of the text that came before that match that we had. This is actually important to think about in context of capture groups, because say we wanted to match file record transcript, but we only want file record transcript as the output of that, because we don't want to then further filter out the .pdf. The suffix will give us the text after PDF, not after transcript, because the full match is on this, but the capture group is file record transcript. So something to kind of think about. And if you have sub capture groups, then you can see kind of things get a little bit more complicated. The iterator version is a little bit simpler, right? Where you can kind of see we have a string regex iterator current match. We start at the begin and the end of the string. So we're treating the string as an iteratable container. And then we're going through the last match. And while the current match is not equal to the last match, we go and we create a current match. We equal our current match, which is the iterator in the beginning of the string. And then we go through one at a time. So current match, we basically output the match string. Current match is just it looks at the full thing, applies a regular expression. Now we've got our iteratable matches, and then the last match. This code is incomplete because last match should equal the end of the current match, but you could also do this with like the iteratable, like it equals start and end, or begin and end as well. But you can see current match is added, and then we're checking against the last match. This line of code does not do anything. but it would ideally equal the last match of the thing. Another approach to this would be to do the for auto, I don't know, where can I, something like this, where you would do for auto match in current match, right? And then you would go, that's a big, yada yada. So you can also do it this way, and you can also do the like for iterable approach and as well, but it's up to you. No, do not save. Cool. And that's the last slide. Hopefully you will enjoy regular expressions as much as I enjoy them, or really, I hope you enjoy them more than I enjoy them. They're very useful. In fact, I've used them to grade your assignments, and maybe I can show you guys a fun little thing. Where is my code? This is something that I made specifically to download projects and code and things from my courses, which is not the best piece of software in the world. Cool. So let me show you. And this is a little tool I created that once I download an archive from my courses, it then takes that archives, expands it, and then unzips a bunch of different things according to the name of the student. And if I can find my regular expression, there it is. And this essentially will find by my course is a very specific pattern of outputting files, and this will ensure that I get that. And you can kind of see the student name is in group 1, so we're doing all of those things, and you can see how that kind of turns into that. And this is in Python, by the way, and you can see I have a program, so I compile it. So it's literally like compiling a little piece of code, and in Python you have this R for whatever reason that tells it it's a regular expression, and then you can match it, and then the result you can go through and do all that stuff. In fact, I do it a couple of different places. There's another regex here that converts something into a file name, and I think that's it. And you can actually fail the regex, right? So if there is no result, then the regex can fail. So this is like a program, like I was saying before. Yeah, so that's about it for this lecture. I hope you guys regex until the cows come home and enjoy it. All right, thanks for watching.